Today is an introduction to polynomials. We are going to define monomials and polynomials and classify them. In the next video, we're going to actually do some graphing. Now, all the vocab. Anytime you start a new chapter, you have all the vocabulary. So what is a monomial? Well, take a look. English will give us a few clues on this. When you see mono in front of any word that's a prefix, that means one. So a monomial is an algebra expression consisting of one term. Now, it can be a variable, it can be a real number. So for example, it could be just x, or it could be the number 3, or the square root of 2, or it can be a combination of both. So here are some examples where you can see that, a 2x, or just the number 4, or 6x squared. All of those are a single term, and all of those are monomials. Now, the degree of a one variable monomial is the exponent of the variable. So if we want to know what degree it is, we simply look at the exponent. So in this case, I would look at the 5 and say it has a degree of 5. Have a smaller problem with the 6b question. What's the degree of 6b? There's no exponent listed there. So we're going to put a 1 in because if it's not listed, it's understood to be 1. So that would have a degree of 1. Now, a polynomial is an algebraic expression consisting of one or more terms. So a monomial is a polynomial, but not all polynomials are monomials. The degree of the polynomial now, because you have multiple terms, is the greatest degree among the individual terms. So you're going to look at all the different terms and figure out which one has the biggest exponent. For example, what is the degree of the following polynomial? 5x to the 4th plus 6x cubed plus 12. Well, take a look, find the biggest exponent. In that case, it's a 4. So this would be a degree of 4. And wow, that 4 looks like it was written by a 3-year-old. Any rate, you guys get the idea. Okay, standard form for a polynomial is very important to do because before we can do any graphing or any analysis of the polynomial, we need to have it in this form. And it arranges all of the individual terms in terms of degree. So you're going to look at exponents, not the numbers in front, but the little tiny ones that are tell you what it's raised to what power. And you want to arrange the terms from the largest exponent to the smallest one. So for example, I have 3x plus 9x squared plus 5, not in standard form. My biggest exponent here is a 2. So this term will come first. So 9x squared. Then a 3x because it has an exponent of 1, and 5 has no exponent. Similarly here, I have 3 minus 4x to the 5th minus 2x squared plus 10. So again, pick the term, with the biggest exponent right there, and that term with its sign comes first, then the term with the next biggest exponent. Then I have two constant terms, and in standard form, combine them. So a positive 10 and a positive 3 combine to be 13. Now you're in standard form. Once you're in standard form, we're going to look at some things, including the lead coefficient. This gives us a lot of information when we go to graph. The leading coefficient is the coefficient in front of the term with the largest degree. So we're going to go find the term that has the highest exponent. So here's 2, here is 5, and the coefficient in front of those would be our lead coefficient. So the leading coefficient in the polynomials above would be 9 and -4. Okay, now we got to name these things because polynomials get huge and we've got to know what we're talking about here. Polynomials have two names, just like most students do, a first name and a last name. The first name is what degree it is, and the second name that we give it talks about the number of terms. So for example, I've got some examples written down here. The first one is just a constant 6. So for degree and degree name, we would say, well, it's 0 degree. There's no x with an exponent, so it's x to the 0 power. Actually, x to the 0 power would be a 1, so it doesn't exist. We'll get to that later. So it's a constant. We call that's the degree name is constant. Number of terms, well, there's just one term there, and we call it a monomial. Now, I'm going to go quickly through these. You'll need to pause the video to get these into your notes. In fact, I talk quickly through the whole video, so feel free to go back over it or pause it at various places. Now our second one has 2 terms, and the degree on this is not written. So there's an understood degree of 1 because there's no exponent listed here. So we're going to put a little 1 in there to help us out. Now, when it has a degree 1, the degree name is called linear. And it has 2 terms, 1, 2, so it's a binomial. So this one would be called a linear binomial. If you graphed it, it would look like a line. Take a look here, 8x squared. Now, our first thing we look at is the exponent. So the exponent is a 2. So that's going to be the degree. So it's a second degree. And as we learned in chapter 4, that's called a quadratic. Now, this is a little confusing because quad in English usually signals 4. And it will be very confusing when we name these because you're going to be tempted to think that should have an exponent of 4. In this case, a quadratic refers to an exponent of 2. And my hope is that just having worked with them for an entire chapter, that kind of is sunk in. Now, there's only one term here, so it's a monomial. So that one would be called quadratic monomial. Let's take a look at this one. I have 3 terms, and my exponent is a 3 on the first term. So my biggest degree is a 3. So that's now called a cubic. And I have 3 terms, so trinomial. And this will help us in English. You think of 3. A tricycle has 3 wheels. A tripod has 3 legs. Here, when we said bi for 2 terms, think of like a bicycle has 2 wheels. So the prefixes will help us a little bit with the naming and remembering the term names. Okay, when you get to an exponent of 4, that's when things get a little weird. The term quartic is used, not quadratic, because quadratic is 2, quartic. And I tell students, those of you who've had to deal with English units of measurement or the American system of measurement, there are 4 quarts in a gallon. So there's, if you can see the 4 here, 4 quarts. So people talk about liters and that kind of thing, which makes way more sense. An American system of measurement is stupid, and I'm not going to go off on that tangent. But if it helps to remember 4 quarts in a gallon, so a 4 is a quartic. I have 2 terms. So bi, again, binomial, bi meaning 2, that's a little more logical. Okay, last one I'm going to do with you guys here is, I think, this one. And it's got 5, exponent of 5. We call that a quintic. So again, get used to these prefixes. Quint, the only place I've seen that used before is quintuplets, when you have 5 children born at the same time. Otherwise, I can't think of anything else where it's used. So a little harder to remember, quart and quint, the 4 and the 5. Now, we had monomial, binomials, and trinomials. When you get up to 4 and beyond, you simply call it a polynomial of however many terms. So this is 4 terms, so we say polynomial of 4 terms. So it gets a very long last name. First name would be quintic. Last name would be polynomial of 4 terms. Okay, now we've got these things named. Let's play with them. We're going to classify this polynomial by degree and by number of terms, but first we have to simplify. That thing needs some help. It is not multiplied out. So now, biggest mistake people make is they square the b and square the 3 and think they're done. Or they'll take the b and multiply it in first. Both of those are incorrect math steps. This is a quantity squared, which means I have to deal with the square, the exponent first, before I do anything else. So what does that exponent mean? Well, that exponent says I have this term multiplied to itself twice. And you can see that this is going to be a lot of work to multiply these out. Now, I like to use distributive property. You can use FOIL. This you learned how to do in Algebra 1, which is basically multiplying out 2 little binomials here. And so I'm going to take the first term, and so I'm going to multiply b times b. Notice I haven't touched the b on the outside. I'm not going to deal with that for a long time. So b times b is b squared. B times negative 3 is negative 3b. Then I'll come to this negative 3. I'll do the same thing. Negative 3 times b, that's negative 3b. Be careful, negative 3 times a negative 3, positive 9. Okay, now you've done that, clean up the stuff inside the brackets. You've got some like terms there. You have, whoops, excuse me, going back to my highlighter here. Let's pick a different color. I've got a negative 3b and a negative 3b. I can combine like terms, so that becomes negative 6b. So now, once you've done this and you've cleaned up the inside, now you can go and do your multiplication with this little b that's been sitting on the outside for so long and waiting so patiently. But notice I didn't do anything with that until I had multiplied out the squared little binomial. So once I do that, b times b squared, that gives me 3 b's, 1, 2, 3, so that's b cubed. B times negative 6b, well, there's 2 b's there, b times b, so that's b squared. And then b times 9 is 9b. So once you've multiplied these out, now you can actually name them. So how many, what's our highest exponent? That's a 3. Go back and look at your chart. When you have an exponent of 3, what's its first name? Its first name is cubic. So this will be called cubic. And then I have 1, 2, 3 terms. 3 terms is trinomial. So that would be named cubic trinomial.